Hey guys, okay, I wanted to review Gaussian elimination really quick today, and then we're going to take a quick quiz over it tomorrow and move on to another method of solving systems. So here we go. Remember, when we're doing Gaussian elimination, we want to get it in row echelon form, which means I want ones in my diagonals. I don't really care what the little squiggly line, I don't care what those numbers are. I need ones in my diagonals and zeros before my ones, okay? So first we need to set up our system in a matrix. And I'm going to go ahead and put this second equation on the top row because it's already a 1x, which means I would already have this 1 up here like I need. So I'm going to go ahead and use that equation first. So I have 1, -1, 1, and -3. Then we can go ahead and do this one second up here. 3, 1, -1, 1. And then that last equation is 2, 1, 1, and 0. So the first thing I want to do, I have this 1 taken care of. So we're good here. Let's see. Check. The next thing I need is for this 0, this number to be a 0. So the 3 needs to become a 0. So in order... our row operations, I have three different operations I can do to a matrix. The first thing is row swapping, which means I just change out 2 different rows. Well, I don't have another row with a 0 in that position, so that doesn't help me. My second operation is multiplying by a scalar that is a non-zero, so that means that that scalar cannot be 0. Well, there's no number besides 0 that I can multiply 3 by to make it 0. So that doesn't help me. Then my last option is multiplying a row by a scalar and adding it to another row. Well, I can add -3 to +3, and that makes it 0. So what I'm going to do is I'm going to look at this. What I'm going to do is I'm going to look at that first row here, and I'm going to say, well, what row can I multiply by -3 to get -3? Well, in the first column of the first row, I have a 1. So if I multiply 1 by -3, that gives me 3. That gives me -3. So that's what I'm going to do. I'm going to multiply row 1 by -3, and I'm going to add that to row 2. And I'm going to put it in row 2. So essentially what we're doing here, I have to apply this to every position. So I'm going to do -3 times 1 plus 3. So -3 times the first value of the first row plus the first value of the second row. And that equals 0. So that gives me a 0 here. Then I'm going to do -3 times 1 times -1 plus 1. So that gives me 4 plus 1 is 4. Then I have -3 times 1 minus 1. That's -3 minus 1 is -4. And then I have -3 times -3 plus 1 is 10. That's 9 plus 1 is 10. And then I'm not doing anything to this last row. So essentially what I'm doing here is I'm looking at, I have equation 1 and equation 2 up here in my equations. So I'm looking at equation 1 and equation 2, and I'm deciding to eliminate my x values. Well, in order to eliminate my x values, I have to multiply equation 1 by -3. So my equation 2 was 3x plus y minus z equals 1. And if I wanted to eliminate the x value, then I have to multiply the first equation right here by -3. So then I would do -3x, -3 times -y would be plus 3y. -3 times positive z would give me -3z equals -3 times -3 is 9. Then I would add these two equations up to eliminate, right? We would add these, so 3 minus 3 is 0. Then I had y plus 3y would give me 4y. -z minus 3z is -4z. And 1 plus 9 is 10. So essentially, when I'm doing this row operation, where I'm multiplying by a scalar and adding another equation, all I'm doing is elimination. That's what we're doing. We're combining our x's, then we're combining our y's, then our z's, and then our constants. That's what we're doing all the way across here. When we did this, we did not change that first equation, right? So we don't change this first row over here. We're only changing one of our equations, okay? And then we're adding them up. So I'm gonna go ahead and erase all that, get it out of my way. Okay, so next thing we wanna do is we need a 1 in this position. So right now I have a 4. So let's deal with that. I can't swap rows. There's not another row. If I swap the last 2 rows, then I've got a 2 in the first position. That messes me all up again. So I can multiply by a scalar. So what can I multiply 4 by to make it 1? Well, I can multiply by 1/4 by the reciprocal. So that's 1/4 times row 2. I'm going to squeeze it in over here. So I have 1, -1, 1, -3. 1/4 times 0 is 0. 1/4 times 4 is 1. 1/4 times -4 is -1. 1/4 times 10 is 10/4, which simplifies to 5/2. So that's 5/2, and then I'm not changing anything in this bottom row yet. Okay, I'm gonna go ahead and erase my little scratch work here. Oops. So I don't run out of room. All right, so my next step here, or here we go, we got this second row taken care of. Now my next step is this number right here needs to become a 0. Oops, I am on the wrong matrix here. Okay, sorry guys. So we need a 0 in that first position right here. So I need to deal with that too. So the first, I can go through my operations. Row swapping doesn't help me. Multiplying by a scalar doesn't help me because I can't multiply by 0. So I need to add something to 2 to make it 0. And the only thing I can add to 2 is -2. So I want to use the row that has a 1 in it, because if I multiply -2 times 0, that's just going to give me 0. And if I add 2 to that, it just leaves me with 2. So it doesn't eliminate my 2. So I'm going to do -2 times row 1 plus row 3, and I'm going to put that in row 3. So I'm not changing row 1. I'm not changing row 2. And I'm going to do -2 times 1 plus 2 is 0. -2 times -1 plus 1, that's 2 plus 1 is 3. Then we have -2 times 1 plus 1, so that's -2 plus 1 is -1. And then we have -2 times -3 plus 0 is 6. -2 times -3 is 6. 6 plus 0 is 6. I'm going to go ahead and erase this stuff down here so it's out of my way. Okay. So now we need to keep on moving. Let me grab a different color here. So now we're looking at this position. I need to get rid of this 3. I need that to be a 0. So again, I need to add a -3 to that. So I'm going to do -3 times row 2, sorry, plus row 3, and put that in row 3. So I have 1, -1, 1, -3, 0, 1, -1, 5/2. And -3 times 0 plus 0 is 0. -3 times 1 plus 3 is also 0. -3 times -1 minus 1 That's positive 3 minus 1 is 2. Negative 3 times 5 halves plus 6 is negative 15 halves plus 12 halves is negative 3 halves. So that's negative 3 halves. As I'm starting to deal with fractions, it becomes easier just to go ahead and convert things to fractions and get a common denominator. So that's all I did. 12 divided by 2 is 6. I just made the 6 a fraction, okay? Okay, so last thing we need to do is we need to make this last position a 1. So I need to make this 2 a 1. So in order to do that, row swapping doesn't help me. Then I can multiply by a scalar. Well, I can multiply by 1/2 to make that a 1. So that's what I'm going to do. I'm going to do 1/2 times row 3. So I'm not changing row 1 at all. Not changing row 2 at all. And 1/2 times 0 is 0. 1/2 times 0 is 0. 1/2 times 2 is 1. 1/2 times negative 3 halves. I multiply across the bottom and get multiply across the top and get negative 3. Multiply across the bottom and get 4. So that becomes negative 3/4. And let me erase my extra work here. All right, so I have 3 equations. I have my first equation up there is x minus y plus z equals negative 3. Then I have y minus z equals 5 halves, and z equals negative 3/4. I can plug these in to solve. So y minus negative would become a positive 3/4 equals 5 halves. So I can subtract 3/4 from both sides. Well, this is the same thing as 10/4. So that means I have y equals 7/4. So we have y equals 7/4 and z equals negative 3/4. And I can plug this in here. So I have x minus 7/4 minus 3/4 equals negative 3. So x minus 10/4 equals negative 3. So I can add 10/4 to both sides. Well, negative 3 is the same thing as negative 12/4. So negative 12 minus 10 is 2. So I actually have x equals negative 2/4, which is negative 1/2. So my solution here is my x value is negative 1/2. My y value is 7/4, and my z value is negative 3/4. There we go. All right, so let's look at number 2. I am going to go ahead and set this up with that second equation first again. So I have 1, 2, negative 1, 3. Then 2, 5. I don't have a z value, so that's 0, 9, negative 3, negative 4, 7, and 1. All right, so I need to my first row is good. I've got a 1 in that first position. My second row, I need to make that 2 a 0. So I'm going to do negative 2 times row 1 plus row 2. And I'm going to put that in row 2. So I have 1, 2, negative 1, 3. And then I have negative 2 times 1 is negative 2 plus 2 is 0. Then I have negative 2 times 2 plus 5 is 1. Negative 2 times negative 1 plus 0 is 2. Negative 2 times 3 plus 9 is 3. And I'm not doing anything to the bottom row yet. Okay, so now I need to make that negative 3 a 0. So I'm going to do positive 3 times row 1 plus row 3, and I'm going to put that in row 3. So I have 1, 2, negative 1, 3, 0, 1, 2, 3. Then I have 3 times negative, oops, sorry, I'm writing that wrong. 3 times 1 minus 3 is 0. 3 times 2 minus 4 is, that's 6 minus 4 is 2. 3 times -1 plus 7 is 4. 3 times 3 plus 1 is 10. Okay, so now I need to make that 2 a 0. So I'm going to do -2 times row 2 and add that to row 3 and put it in row 3. So again, I'm not changing the first row, not changing the second row. I have -2 times 0 plus 0 is 0. -2 times 1 plus 2 is 0. -2 times 2, ooh, my iPad's gonna die. Plus 4 is, well, that's -4 plus 4 is 0 again. Then I have -2 times 3 plus 10 is, that's -6 plus 10 is 4. Well, my equation on the bottom row here tells me that 0 equals 4. And that is not true. So we're going to say here that this has no solution. Boom, we're done. All right, if y'all have any questions, let me know. Remember, we're going to take a quiz tomorrow. The Gaussian elimination, I'm not going to take a grade on, but I did post the answers. So go back, check your work, make sure you know what you're doing. We're going to